All right, so those problems from last time were like you had let's look at one where it's maybe you've got 7 objects and you're trying to choose from those 7 objects, you're trying to choose 4 of them. All right, so we saw that on the permutation side, for permutations, the order does matter. So this was the situations where, let's say you're trying to put those 4 objects in a line, and these are actually pretty easy to calculate. If you're trying to fill four spots with 7 options here, you could just do what was it? Yeah, you had 7 options for the first one, 6 options for the second, then 5, then 4, and we said we could just multiply these. All right, so this was, I think, 840. Let me double check here. 2, yeah. So on the permutation side, there's 840. But for the combination side, it wasn't so simple. All right. So, you could simulate it with, say, A, B, C, D, we said, and then we had to map that over onto the permutation side and ask, how many different permutations are there for A, B, C, D? And that'd be A, B, D, C. Well, we found out that because there are 4 objects, there were going to be 4 factorial permutations of those 4 letters. All right, so which that turns out to be 24. And so we were able to answer the combination question by just taking this 840 and dividing it by 24. What is that? 840 divided by 24 gives us 35. Now there's this thing that we have not talked about very much. I've mentioned in class, but not virtually, I don't believe. And that's Pascal's triangle. We're going to do some stuff with this later, but it has a lot of neat properties. So the way it works is ones, you're going to draw it with ones going along the edges here. And if you take the 2 cells that are adjacent and then add them up, that goes right below it. So 1 and 2 make 3, 2 and 1 make 3, 1 and 3 make 4, 3 and 3 make 6, and so on and so on and so on and so on. But you can use this for several things, one of which is combinations, answering combination questions. So ours was 7 choose 4. The way that I actually remember, I don't usually reach for the permutations and then reasoning it out way. I usually reach for Pascal's triangle. What you do is you go down to the 7th row, so the one that has a 7, and you go for the 4th entry on that row, but you have to ignore the 1, I guess. So this would be 1, 2, 3, 4, and that's where our 35 comes from. All right. That example from last time, I think we had a basketball team that had 11 players on it, and they wanted to choose 5. So 11 choose 5, where the order doesn't matter. All right. Combinations, not permutation. We count over 5 spaces here. So this would be 1, 2, 3, 4, 5. 462 is our answer from last time. So this is a kind of a shorthand trick for answering those combination questions, all right?